Assalamu alaikum, student. In today class, I am discussing the A-level practicals. Okay, what are the definition, topics, and measurements coming in A-level chemistry practicals? Just like this is the important topic of A-level chemistry practical. Enthalpy change and measuring temperature. This one, when you check the past paper of chemistry, you check there is question coming belong to enthalpy changes and temperature. Now here I am discuss uh, how we calculate the enthalpy change and the temperature. First, there is given the measuring temperature. In an uh, enthalpy change practical, the temperature change need to be accurately measured. This is done by minimizing heat loss or heat gain from the surrounding. When we are checking the surrounding temperature and we uh, check this is done by the minimizing heat loss or heat gain from the surrounding. When we check the um, heat loss and heat gain, heat minimize according to surrounding or heat loss or heat gain according to surrounding. Now, this heat loss and heat gas gain we uh, can be checked with the help of temperature. Okay. Now, for this temperature measurement, we are using like structure. We apparatus. We use a stand and we fix a thermometer in this stand. Thermometer we put in the uh, container. Here we are using the polyester cup. Okay, these all things there is need why we are using the polyester cups and why we will discuss here. Enthalpy change practical, the temperature change need to be accurately measured. When we are discussing the enthalpy change, now there is need first we measure the accurate temperature. For enthalpy change, there is first need accurate temperature measurement. When we accurately measure the temperature, then we can easily measure the enthalpy change. This is the first step. We accurately check the temperature measurement. Need to measure accurately. This is done by minimizing heat loss or heat gain. For accurate measurement, this is necessary. We minimize the heat loss or heat gain. From the apparatus, we minimize the heat loss and heat gain. Now, this is belong to accurate temperature measurement. We minimize the heat loss and gain. When a lot of heat loss form or heat gain form, we cannot measure the accurate temperature. For accurate temperature, it is necessary we minimize the heat loss and heat gain. Clear? Now, for enthalpy change, there is a necessary we must measure the uh, temperature accurately, and for accurately temperature, there is need minimize the heat loss or heat gain. A polystyrene cup and lid is used to insulate the reaction mixture from surrounding. We put reaction mixture in this polystyrene cup and also a lid. Now these two things, polystyrene cup and lid, these polystyrene cup and lid, this lid and polystyrene cup. Now these two things we use, these are minimizing the temperature loss. These polystyrene cup and lid insulate the reaction mixture The stirrer is used to ensure thermal energy is spread evenly in the reaction mixture. We use a stirrer also here. This is with the help of this stirrer, we equalize the temperature or heat spreading equally in the solution. Now, this is necessary. The bottom of the thermometer must be in the reaction mixture, and when we calculating the mixture temperature, we use the bottom in the we dip the bottom of the thermometer in the mixture. And electronic temperature sensor also and data logger also software could be used to plot the graph accurately. If not, ensure you read the scale carefully. Okay. Now there are two things here. We use the thermometer and read carefully the reading. If we cannot read carefully the reading, there is another way. Electronic temperature sensor we use or data logging software we use. With the help of this, we can accurately measure the temperature. Then we plot the graph also accurately. If not, ensure you read the scale carefully and reading of scale carefully scale required. It's mean when we are doing practical, number one, temperature measurement, accurate temperature measurement required, and for accurate temperature measurement, heat loss and heat gain controlled. No, there is heat loss and heat gain control. And for accurate measurement of temperature, no, it is necessary we use a good thermometer and dip the thermometer in the solution, bottom of the thermometer, and read the reading carefully. And data logger we also use sensor and data logger, temperature sensor and data logger. Our careful reading required for temperature measurement. Then we can easily calculate or accurately calculate the uh, enthalpy change. A flame calorimeter could be used to improve accuracy. A spiral chimney is made of copper. Flame is enclosed. Fuel burns in a pure oxygen rather than air. Flame calorimeter we are also using. And with the help of flame calorimeter, we also get the reading. No, I'm telling you what the flame thermometer, what is the structure of flame calorimeter? No, this is the flame calorimeter. This type flame calorimeter also used. In this calorimeter, we also control the heat loss. No, there is an inlet, there is an outlet. This is the flame calorimeter. And with the help of flame calorimeter, also we there is a water bath, there is a spiritual thermometer is there. Now, this type of apparatus arrangement we use in the practical when we are calculating uh, calculating the enthalpy change. A flame calorimeter could be used to improve the accuracy. Spiral chimney is made of copper. In this flame is enclosed, fuel burns in pure oxygen. Now, example for temperature change graph. We draw the graph, the reading of temperature change and time. We note this one, okay? Now, when this type, basically the temperature is constant, then decreasing. This graph are constructed to eliminate the error that is due to the heat loss to the surrounding. This is get a more precise uh, temperature change from the cooling curve. There is a cooling curve for an exothermic reaction. In exothermic reaction, what happens? The temperature decreasing. The horizontal reflection of the diagram on the left is the heating curve occurring in the endothermic reaction. The same principle applies. No, no, this is the curve. Basically, the temperature constant, then decreasing. Temperature change form. Now, constructing to eliminate the error that is due to the heat loss to surrounding this, get a more precise temperature change. When we draw the graph, then we can form a precise reading of temperature. For cooling curve, for an exothermic reaction, the horizontal reflection is of the diagram on the left is heating curve that occurs in the endothermic reaction. The same principle applies. Now, this constant also saying the telling the heating curve. This constant line also telling the. Now, how we calculate the enthalpy change? All solution have the heat capacity of water. Neglect the specific heat capacity of the calorimeter, any heat absorbed by the apparatus. In this calculation, we neglect the heat capacity of the calorimeter. Reaction of dissolving is not incomplete or slow. Dissolving is not incomplete or slow. We accurately dissolve. Density of the solution is taken to be the same as water. We normally density of solution take as the water density. None of the water could have evaporated. Room temperature is unchanged and no incomplete combustion. These are the some things, some assumption we do for the enthalpy change. First, we solution have the heat capacity of water we use. We neglect the heat capacity calorimeter. Reaction or dissolving is not incomplete or slow. Density of solution is taking to be same as water. None of the water could have evaporated. Room temperature is unchanged. No incomplete combustion use. Due to these assumptions, the values of the calculate may vary from the data book value of the enthalpy. Uh, there is change comes when we are doing these method with the data logger, data booklet. Before the practical being used to method of measuring mass, first we measuring the mass of a solid, then calculate the moles of the solid by using the formula number of moles, mass relative multiplied by mass given. Molecular relative mass multiplied by mass. No, we calculate with the help of this formula. The energy changes from Q, energy change we calculate with the formula. Mass, specific heat and change in temperature. Energy is in joule, 1000 to convert kilojoule is mass of water. Also we doing this one, 1000 change. First we calculate the mass, then we calculate the number of moles with the formula of number of moles, and then we calculate the energy change. Molecular relative mass with moles, the number of moles come, molecular relative mass multiplied by mass, we get the number of moles. The energy change we get with QMC delta theta, energy 1000 which convert into kilojoule, specific capacity of the water 4.18, and temperature change with the graph, and all these things we calculate. Now, the standard enthalpy change comes kilojoule mole, kilojoule per mole, mean energy upon number of mole. Now, this is the uh, exothermic or endothermic standard unit we are using for the enthalpy change. Change divided by the energy, energy we get, enthalpy energy we get, enthalpy change energy we get kilojoule per by mole. Or if exothermic add a minus, exothermic we minus, and endothermic we add plus. The standard unit are kilojoule per mole. We use this standard unit. Now, these are the way by which we can calculate the enthalpy change. There is complete method giving how we calculate enthalpy change of copper sulfate. Now, first what we do, weight the copper sulfate. 3.90 to 4.1 gram anhydrous copper. Anhydrous means water is not present, only the copper sulfate is in a dry stop weighing bottle. Keep the stock of a solid in closed container. During weighing, in weighing we close the container. The precise mass should be recorded. Wash the container with the solution to be used. Dry the cup after washing. Then construct a suitable table of result to allow you to record the temperature at uh, minute interval up to 15 minutes. And time we are using for temperature change 15 minutes. Mass we are using 3.9 to 4.1. And then dry the also container, wash the container, dry the container. Then using a measuring cylinder, place 25 cubic centimeter deionized or distilled water into the polystyrene cup and record the initial temperature uh, of the solution. 25 cubic centimeter deionized distilled water into the polystyrene cup and record the initial temperature before starting. Start the timer and then continue to record the temperature each minute or 3 minutes. Allow the water to stand for some time. Stir the liquid continuously. Place the polystyrene cup in a beaker to extra insulation and support. Place the polystyrene cup in the beaker of the extra. We put the solution in the polystyrene cup, then put into the beaker. Clamp thermometer also place if two reactant solution, then temperature of the both solution need to measure before addition or average temperature then. Ensure that they all at room temperature basically. Temperature allowing a better average temperature. Obtain polystyrene beaker may good calorimeter because they are good insulator and have high specific heat. Polystyrene cup or the calorimeter we use in this situation. There is no loss of temperature form in this situation. Now this is the practical for the enthalpy change. For exothermic, there is a state curve. And for endothermic, there is a change in the temperature form with time. With the help of all these calculations, we can calculate the enthalpy change of a solution. Here we are calculating the copper sulfate and copper sulfate. First we weight it, then wash the container, then we prepare solution of the copper sulfate. Use the measuring cylinder, place 25 cubic centimeter water. In water, we put the copper sulfate and record the initial temperature, then time, and then continue record the temperature. After 15 minutes, we record the temperature. Now, there is a solution. And solution heat, what's happened with solution heat? Solution heat first, if increasing, then decreasing, it's been exothermic. If first decreasing, then increasing, it's been it is endothermic reaction. Now, these are the steps by which we can calculate easily the enthalpy change. We know the temperature, we know the mass, and but we use the same assumption enthalpy specific heat near to the water. We use this one, and we use the formula Q equal to mc delta T with the help of this. And for number of moles, we use this formula, and we get easily the number of moles. Now, these all steps when we do, we get the reading or enthalpy change accurately. Okay, student, I will tell you in next class about the chemistry practical next topic tomorrow.